example 19. This is an exam style question. There'll be quite a lot of marks for a question like this. And we're going to take it sort of one step at a time. It's telling us about this quartic equation that we've got to solve. So we've got z to the 4, 2z cubed, 2z squared, plus 10z plus 25. And it's told us that they already know that one of the roots is minus 2 plus I. So straight away we know that its friend, its conjugate pair, will be minus 2 minus I. So from these two roots we know there must be a quadratic equation which gave us these two roots. Now what you might want to do at this stage is pause video for example 19 and actually watch the video for example 20 which shows you how to find this quadratic. I'll go through it as well here, so either way. So we're going to work out what the quadratic is. If these are the roots, then the actual quadratic must be z minus 2 plus I and z minus 2 minus I. So thinking back to example 18, when we found out the root was 3, we knew the factor was z minus 3. Well, same thing here. If the root is minus 2 plus I, the factor is z minus 2 plus I. Okay, so you're going to do lots of pausing on this example. What I want you to do is I want you to pause that, pause the video, multiply all that out, and I want you to tidy it up into a quadratic equation as simply as you possibly can. So hopefully when you multiplied everything out and lots of things cancelled, you got z squared plus 4z plus 5. Now if you're not quite sure how that works, watch example 20 which goes through that step in a bit more detail. Okay, so that's the quadratic that gives these two roots. The next thing is, if we have a quartic, we're going to divide it by the quadratic and that will give us another quadratic which will tell us the other two roots. So either by inspection or algebraic division, there's going to be another pause in the video in a second, write out the quartic underneath and then put the quadratic at the front, z squared plus 4z plus 5. Go through and do the algebraic division. I'll do the first step with you because you may not have done many like this. Z squared into z to the 4. In other words, what would you multiply z squared by to get z to the 4? It would be z squared. And then you multiply z squared by this equation at the front. So that would be z to the 4 plus 4z cubed plus 5z squared. Make sure you line up the columns. And then when you subtract, that disappears. You get minus 2z cubed minus 3z squared, and then you bring down the next term plus 10z. So pause the video, continue with that division, or do it by inspection if you prefer. And when you did all of that, you should have got a 0 at the bottom because we knew this was a root, a factor, sorry. And at the top, you should have got z squared minus 2z plus 5 as your other quadratic. So if you didn't get that, again, you need to just stop and have a bit of a check. So we know two of the roots, a minus 2 plus I and minus 2 minus I, so that's two of the answers, but a quartic has got 4 roots, so the others come from this quadratic, and I'm looking at it and I can see it doesn't factorise, so quick quadratic formula, minus b becomes plus 2, and then I had a go at this earlier so you can trust me if you like at this point. It works out to be minus 16 under the square root, and then we've got 2a on the bottom. So simplifying that, 2 divided by 2 is 1. Square root this first before you divide by 2, so square root of that becomes 4i, and then you're going to half it, so that's 2i. So in this case, we've got one of those graphs that never touches the axis, and we looked at them earlier and they look a bit like this, quartics that never touch